All right, so
Thank you.
today is Wednesday, January the 27th. All right, so we are going to start with the comment section. So let's go back to the slides. So questions. So let's see. On the Seaborn lesson, when you were talking about the facet grid, why do you do G is equal to SNS facet grid, something blah, 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 and G is equal Gmap? Doesn't the second line completely replace the first line since you're defining the same variable twice? Okay, so guys, the answer is no. If I was defining a variable like, or even a data frame, say that, okay, data frame is equal to something, and in the next line, data frame is equal to something else, yes, I'm replacing that data frame. But here, this is part of that, object-oriented coding. I'm defining an object here, and I call it G, right? And that G is going to be a plot out of the Seaborn library, and we are doing a facet grid. So if I go ahead and add if I do G dot something map, it's going to keep adding layers to that plot which already exists, right? So I can do G dot something, G dot X, G dot map, G dot whatever. Whatever we're doing here, it's not going to replace the previous thing. It's going to keep adding layers to that, right? So that was just some technical question. And guys, well, I'll show you a video on YouTube, but my point is that don't lose perspective. These are all good, by the way, right? All good, but do not lose perspective for the course. The goal is not to become an expert in Python, okay? The goal is to become an expert in the theories of machine learning. We'll learn it, and then at the end of the day, you can apply it in Python, you can apply it in R. When you go to work, you can apply it with the third program. We never know, right? So do not lose perspective. This is really important. All right. And second one, I had some question about the order you need to write things in the code. So when looking at the contextual hub, there is an order, for example, X, Y, data, and etc. So do you need to type everything in that order? Or if you label everything, does the order matter? So the answer is no. If you label everything, you don't need to order. You don't need to just stick to that ordering. But if you do not label things, you have to make sure that you go with the right order that they offer. Is it clear, guys? So for example, if you want, you can put, if in the documentation there is X, Y data, so you have, and you don't want to put labels, so you have to make sure X comes first, Y comes next, and data comes next. But you can start by data is equal something, so you put it first. You don't need to just stick to that order, right? So that was the second one. Yeah.
I mean, I don't know why you would do this, but say, for example, you're doing some type of function like that, and you do like data equals something, and then you don't want to use labels after that for some weird reason. Would it then start at X, Y, or?
I know. I haven't mix and match, honestly, but I guess it's going to start from the beginning. Yeah, okay. But I haven't mix and match myself. Yeah, so I assume that if I do data is equal something, and then A is going to be X, B is going to be Y. But we can try it now. Yeah, good question. I need some help installing Seaborn. I'll go over it very quickly. And then is there a discrepancy between the axis? Okay, this was a good question, actually. It says that is there a discrepancy between the axis label from Numpy and Pandas? The answer is no, okay? But I see where the question is coming from. I think when we're doing Numpy in one of those matrices, it says that, okay, 0 is reserved for vertical and 1 is reserved for horizontal. But we know that in Pandas, we usually say 0 is rows and 1 is columns. Guys, I want you to learn how to read the documentation of the functions because it all depends on the author of the package. So, and because Python and R are not open source programming, so they get better and better over time. So usually we don't see all the packages are consistent with each other, right? So some packages they use x is equal to 0 as column and 1 otherwise. And some functions in a specific package is doing completely the other way around. So you should not be worried about that. If you look at the documentation of the function, it says that usually the documentation x is equal to 0 is reserved for rows, and then x is equal to 1 is reserved for columns. Okay, but don't become super worried about memorizing these things. Never do that, right? Never memorize things like that. It is good to know, but it's not worth memorization. All right, so that was all the questions. Now I want to go over comments, and the reason that I would do it this time, I want to spend some time because I received lots of overwhelmed comments, and this is completely normal. Okay, I want you to understand that this is completely normal. So let's go over some of the comments together, And then we are going to jump into our Jupyter notebook and cover the EDA for today. So these are the comments, and I really want to share them with you because I want you to feel that you're not alone. This is completely normal. So the first one, I feel very shaky in my coding ability, but I really enjoyed being able to go through the notebooks while watching the videos and playing around with them a little bit to make sure I understood everything, what's going on. I'm excited to learn a new language and hope I can be patient with myself. This is key. That's why I really highlighted it. Be patient with yourself. This is not something that you're expected to cover in a week or two or even a year, okay? Be patient with yourself. And I feel that I understood everything while I was watching, and however, I'm still very bad at syntax. What is the best way to practice? So the best way is, running through the videos and Jupyter notebooks or trying to do things from scratch. As a beginner, I want you to start from scratch, right? So have the Python, my notebooks open and I don't know, or even print them out or whatever works for you. And then try to code from scratch. Do not run the codes that you already see on the Python. Right? Try to type in from scratch. When you type something, put a dot, press tab, see what are the options, right? And then do something like this. So as a beginner, start from scratch, but as we go through the more advanced materials throughout the course, I don't want you to reinvent the wheel, right? Just look at the code that I provide. You can use it as a template, okay? So I hope that answered this question. I'm not going to lie, the Python crash course was a lot. We talked about it. Yes, it was supposed to be a lot, so take it easy. It gave me a good overview, but I still largely do not understand Python. I have never used Python before, but my background coding is fairly limited. Hopefully it will come with practice. Yeah, the key term is practice and a lot of Googling. Yes, Google is your friend. Google, YouTube, Stack Overflow. Stack Overflow is my best friend when it comes to coding. Are you guys familiar with Stack Overflow? Just Google whatever code you, I have some examples for you, and I'll teach you how to Google things when it comes to coding today when we're doing a live example. I have a huge desire to master Python. That's it. I didn't read the rest of the comments. This is all I need. I need you to have a huge desire to master something. So this is all I expect from you, right? So you can read the rest, but have had limited exposure. I don't care. Okay, I had some limited exposure someday too, right? But it all comes with practice. So this is awesome. Huge desire to master Python. It's going to be difficult, right? Nothing easy is fun, let's say. Easy is not fun, right? So if everything was easy, then you didn't feel accomplished after doing something, right? So my point is that try to push harder. If you're sleeping 8 hours a night or 7 hours, make it 6. I don't say make it 2 or 3. Make it 6, just cut 1 hour and then practice coding, practice doing things in Python. It is worth your time. I guarantee you guys, it is worth your time. At the end of the day, at the very least, it tells you if this is something for you or not. This is the very least outcome of this exercise, right? You realize at this age, okay, this is not my type. Let me do something else. So this is the minimum outcome that you can get out of this 3 months of sleeping 1 hour less. Does that sound fair? Okay, and it's all for your sake. The shortcut videos, video is a gem. Thank you so much. I didn't know that we have this English expression, so I learned it. So, yeah, my class is a gem. That'll speed me up quite a bit. Yeah, the shortcuts are awesome, especially when it comes to Jupyter. Okay, the shortcuts are really, really awesome. It save you a ton of time. And I don't know, it feels good. It just feels good to use your keyboard. I don't know, if you're with me, you understand what I'm saying, but it just feels good to not use the mouse sometimes. And not only time-wise. I have a Mac, so this was important for me because we have many Mac users here, right? So I have a MacBook, so some of the directions given, I was unable to follow at times. I'm not quite sure because we are using Anaconda, and it really doesn't matter if you're on a Mac or Windows. You should be able to follow everything, and it's exactly the same either in Mac or Windows. In R, RStudio is different, and Jupyter Notebook, they're exactly the same. So you should be able to follow everything that we do in the class. Well, this comment has the continuation, so I cut it out, but it says that the directory is different. Yes, the directory is going to be different. So if you're on Windows or Mac, my directory is definitely going to be different than yours, right? So if you see that the name of the directory, you don't have it on your computer, that's completely normal, right? Because it's regardless of your operating system, right? You can be on a Mac or Windows, but our directories are obviously different. Again, if I didn't answer your question, please reach out and we can have a Zoom meeting. You can share your screen with me. I'll go over it. There's a lot of code to keep in mind. Don't do that yourself. Do not memorize these codes. Okay, guys, do not memorize it. I cannot emphasize it more. Learn the basic of coding, but do not memorize the name of the function. They are going to change. By the time you graduate, who knows you're going to work with Python or not? Everything is going to become automated. If it was a computer science class, my approach was completely different. I said that you have to memorize some of these things. But this is not computer science class, right? It is good you learn them, but don't torture yourself by memorizing the name of the functions, right? I never, I've been teaching R for quite a while now, and let's say machine learning in Python in 2 semesters. I still don't memorize these things, right? So I Google them. I don't know what is it. I quickly Google them, right? So don't do that to yourself. And again, don't lose perspective. Definitely feeling overwhelmed. Again, that's normal. If you felt otherwise, I would be surprised. And you will feel overwhelmed through the rest of the semester. Okay, that's okay. As I said earlier, I'm trying to push you so hard. We are gonna get something out of this course at the end of the day. And again, nothing is going to be easy. I feel comfortable with the basics, but I feel refer back to the videos and Google Stack Overflow. Yeah, this is Ryan's comment, I believe. Yeah, I like that comment. So Stack Overflow is your best friend, right? To help me throughout the semester on more specific comments. Overall, a very helpful crash course. I'm working on learning how to code using Python. I'm getting the same feel. Okay. So he or she is a student who are taking econometrics with me, but I want you to just look at this statement. I'm getting the same feeling I got when I first encountered art, but confident the challenge will smooth out throughout the semester. So if you have taken econometrics with me, you know that it's going to feel overwhelming, but it's going to fade away. I promise. Just hang in there, right? Just push yourself a little harder, and you will survive. Okay, that was all about the comments. I hope that I answered all of them. The only one which is unanswered is installing the Seaborn, which we're going to do right now. So let's, and by the way, if you didn't notice, you can go ahead and pull requests to the repository. So if you go to the repository of the class, which is ML 2021, and then you go to repository pull request, you can fetch, but I encourage you to do pull because fetch is push and pull. And if you have made any changes by accident, it's going to push it through my repository. You're going to get an error. You don't like it. So just always pull. When you pull, then go back to the folder. Make sure you go one folder up. And then you copy and paste. I'm not going to copy and paste it on my computer because I'm the owner, but I want you to copy and paste it. Keep your own version somewhere, right? So this is your own version. Then open up this one and start playing around with that, okay? Do not open my directory and start playing around with that because it's fine, you can, but at the end of the day, when you close it and then you want to open up the desktop next time, it says that you make some changes, you want to push it to the original repository. You're urged to do that, but you cannot because you don't have access. And then there's going to be maybe sometimes even hundreds of error messages out there, which is bothering you. So I don't want that to happen, right? So I want you to just quickly make a copy. And then, for example, here, I added this EDA for our class today. So if you go ahead and fetch the repository, you will see that this EDA is new. So I'm going to go ahead and use my own repository, but you follow along with your own, the copied version on your own computer. So this is the one which is on the original repository. And we are going to cover the EDA explanatory data analysis using the wage data set. Okay, one last thing before moving on. So let me quickly show you what I meant by don't torture yourself. So there's a package, and it's not efficient. It's not that's working best for many of the comments that we have, but you'll be surprised. So there's a package called text to code, and it's literally will transfer, and this video doesn't have a sound. It transfers whatever you're typing into a code, right? So it says that load this CSV file. So you just type in English, the code is going to be typed out, right? Show all columns from df, so we know that it's df columns. Show 5 rows, we know that it's df head. And it's get more complicated. Display correlation matrix, we know that it's going to use df core. And plot histogram, are you following? So the coding is becoming easier and easier and easier, right? So, and maybe today is not efficient, but to me, it's a fact that in 5 years, the coding is going to be completely different for non-computer science users, right? For developers are behind the scene are doing these jobs. But for us as a consumers of machine learning and things like that, your first priority is to learn the theory and mathematics behind machine learning, not the coding part, right? The coding part is a plus, but don't get overwhelmed by Python. I know it feels good if you learn it, and I highly encourage you to do that because it's a plus. But your job should be, again, starting using your econometrics or finance, marketing knowledge to add some context to whatever you're doing. Okay. So that was maybe such a relief for many of us that are scared of coding. All right, now let's start the class. So I'm going to go ahead and do command cmd. Okay, is it working? CMD. So if you have installed your Python through Anaconda, you should be able to open up the Jupyter Notebook using the command. So on Mac, it's terminal, and usually by default is to start with base. If the terminal is not base, so you may get an error, but if you have installed through Anaconda, hopefully everything is fine. But if not, just send me an email or the TA. We should be able to fix your computer. So I'm going to go ahead and do D because I have everything in, sorry, CDD. I have everything in my D drive. What am I doing? What? Oh, because this is the other computer. Oh. Okay, I'm using, so this is my computer, right? If I do terminal, is it mine? Yes. Okay, sorry, this is my bad. This is my office computer. There's no D drive. That was my home computer. So there, in my office computer, there's no D. So I just open up the Jupyter Notebook in the root directory. So let me close it out and tell you. Maybe I can open it up somewhere else. Well, these are your comments. All right. So let's start from scratch. So I'm going to open up a terminal. And you can always take directory, see what do you have on your computer. So this is a directory. So for example, I can go to my GitHub somewhere. There's a chance that I have GitHub. I don't have GitHub, but anyways, I'm navigating through folders, so that's the point. So I don't remember where was my GitHub. Actually, these are good things that's happening, right? So maybe you have the same problem. So GitHub is in documents. Okay, I have to go under the documents and then maybe GitHub, right? This is, you don't need to necessarily do that, but it's always to keep track. So I can do CD documents, right? And then I can do directory, see what I have. And then, so I have GitHub. I can do CD GitHub. So now I'm in my GitHub folder, right? So I can even go to the classes and class 3, but I just want to start it from here. So I say, let me actually, yeah. So I say, okay, Jupyter Lab. If you do Jupyter Notebook, it's going to open up a Jupyter Notebook. If I do Jupyter Lab, it's Jupyter Lab. So we're going to work with Jupyter Lab. So as you can see, by default, the root is going to be my GitHub account, right? And now I have a copy. So make sure that you open up the one that you have your name at the end of it. And then I'm going to open up with this one. So then we go to classes, and we go to EDA. So this is, and you have to make sure that the logo is there. Otherwise, you don't see this logo. Again, these are, all right. So we are now in the Jupyter Lab or Notebook in general environment, right? So the first cell is a markdown. So again, if I double click on it, you can see how we can add a picture. You have to make sure that it's in the same root. And then this is markdown language, right? So let's talk about explanatory data analysis. So the goal for today is to review almost all those Python crash course notebooks, not all of them, but many of them, by doing an exercise together. So this is called EDA, Explanatory Data Analysis. This is a first step that for you guys as a data analyst, or if you want to do any kind of machine learning project, you have to start from EDA. You have to look into data, do some visualization, and get some context out of the data, and then try to jump into the model, right? So we never start by running machine learning models blindly, right? So we have to first look at the data and play around with the variables and maybe visualize them, get some context, and then you'll see which model is going to work better for our data set, right? Explanatory data analysis. So I think here I put some links for you. So if you click on them, it will navigate you to either the Wikipedia page or some examples. So if you click on this example, it will just, guys, you have to practice a ton. And so this is another good website toward data science. So when you're Googling things, just keep an eye on these keywords. You know, toward data science is a very good one when you want to learn something in general with examples. Stack Overflow is your best reference for coding, right? And so this is what we mean by EDA, right? This is EDA is an approach to analyze data set to summarize your main characteristics. So let's look at a data set. So first, you have to import some libraries. You can import the packages and libraries down the road whenever you need them, but it's a good practice if you import all of them at the very first cell. So let's do that. We're going to import Numpy as NP, Pandas as PD, Matplotlib pyplot as PLT, Seaborn as SNS. And here's a trick. SNS.sets, you know, if I use a Matplotlib functions, and I like the theme of the SNS Seaborn package, I'm going to say, okay, SNS set. If I don't pass anything by default, it's going to use the default theme for the Seaborn. But this is a cosmetic thing. Just I'm trying to tell you what each line does, right? And if you forget what I said, or if I was not clear, just make sure that you do something like this: SNS.set, and then Google it, okay, and see what you get. Okay. And guess what? We're going to look at the wage data set. I know my econometrics students are sick of it, so that's why I'm using it. So, and the reason is that it's a simple data set. We use in econometrics a ton, and we know, at least I'm going to give you a quick preview for those of you who haven't seen this data set before. But it's a very simple, straightforward data set, keeping track of the wages with some few explanatory variables, right? And the data set is already here, right? So make sure that you open up the folder, and if you just open up that notebook, you should be able to run this code as is, right? So you don't need to pass the directory like C back. You don't need to do things like that, okay? If you just pass the name of the, well, actually, let me show you what I mean. If I go ahead and erase this one, if I do, let's quotation, and then if I press tab, it's going to give me all the suggestions, right? So it's going to go to that folder and show me what do I have there. So then let me see, we have a wage. We should have wage data set out there. Yeah, wage CSV, right? I could have done something like this, right? So you don't need to pass the directory. And then look at the head of the data set. So this is a Pandas data frame, right? Now I can use all the functions from Pandas, right? So for example, if I do df dot, so again, I told you as a beginner, I want you to start by coding from scratch. So have a completely new cell and then start typing, for example, df dot, press tab, see what options you have, right? So it's not giving me my options yet. Well, sometimes it does, sometimes it doesn't. If you're in a for loop, it doesn't, but times like this, it should. I don't know. Yeah. So let's look at the head of the data set. We can open a contextual help by doing Control-I, and let's keep it here. Okay. Now let's talk about the data set. So data set, we have a wage, hours, IQ, education, experience, tenure, age, married, black. So these are categorical variables like mother education, father education. Okay. Then then our goal is to summarize the data set first. So a good function that we can use is info. So if I do df.info, and again, there's this documentation, just open up here, you can see what do we have. If I don't pass anything, everything has a default value. For example, verbose is none. Frankly speaking, if the universe of Python codes has 100 units, I know 1 unit, okay? So that's if I want to put it fairly, okay. So there are lots of features in the functions that I don't know, but that's not the goal for me. Just realize what you want to do with whatever you're learning, right? My goal is to learn machine learning, not necessarily become an expert in Python, right? Python is a tool. Is a very powerful tool, by the way. So I get the information of the data frame. So it seems that we have 935 observations, but this is the first thing that I want you to pay attention, right? Guys, your homework 2 is going to be an EDA. of another data set, which is from Kaggle competition, you're going to follow these steps one by one. So either rewatch this video very carefully or listen it out here now, okay? So the first step, again, you have to pull up the data like this, look at the head, look at the variables, and then this is your first thing. Look at the information and look at the type of the variables, right? So for example, wage is a number, float, integer, these are just integer 64, 32, these are basically numbers, numerics, right? The float is more precise than integer and etc. And even more precise than double. Again, for example, you don't know what is floor 64, right? So this is what I mean by Google is your best friend. So do float 64 versus int 64, and then see what you get. So I don't know, there's GitHub, well, Stack Overflow, maybe. So this is for converting. So if I want to see the difference overview of Python data types, so maybe, yeah, okay, there's something here. I can see float 64. The usage is just a point numbers. And then if you want to compare them, you just read through these things, right? So integer numbers is integer 64. Floating point numbers is float 64, right? So this is what I mean by Googling things. You know, try to Google things a ton. This is how you learn coding, okay? And so we looked at the type of the data sets, and I know wage is numeric fine, hours is fine, IQ, education, experience, tenure, age, married and black. So married and black, right away I realized that I don't like them to be integers, right? I want to change them to categorical variables. Is everybody following? Because married and black are categorical variables. Married can be 0, 1, black can be 0, 1. So I quickly keep in mind that I have to change the type of these variables, okay? And then I can leave the rest of them alone. So for example, I have mother education. It's a float maybe because there are decimals. Father education, the same story. But I'm fine with that. If you see an object, which you will see for your homework, it's a bad sign. Object means that we don't know what it is. You have to definitely change the type of it, right? So, and how do we change the type of these things? But there's a trick before looking at, let's say, or guessing that the married and black should be categorical. The trick is that let's figure out what should be the type of each features, right? So let's look at the number of unique elements for each variable, right? So for example, if I have a black, what do you expect to see the number of unique elements in that variable? 2, right? 0, 1. You can look at the head of the data set too, right? Black, we have 0. Maybe if I look at the tail of it, I see a bunch of I may see a bunch of, a bunch of ones too, right? So this is the end of the data set. The bottom of the data set, head was the head of the data set, right? And look at that, there are a bunch of NAs as well. So I have to clean these things as well. So let's see how we do this. Let me actually keep it tail. And the cool thing of doing things in the in GitHub is that now when I make changes at the end of the class, I push these changes to the repository and you pull requests again, you get the updated version right away. Okay, you don't need to wait for me to go home and update things on Canvas. All right, so let's figure out what should be the type of each feature. So I'm going to come up with a for loop. I say that for columns, and this is what I can call it X, Y, whatever. For columns in df column, so let me give you a hint. So if I just type df columns, so what do I get? You see, I start typing and then I do tab. It will autocomplete for me, right? If I do df columns, it will give me the name of the columns, right? Wage, hours. So when I write a for, this for is going to go over these names. So first start with wage, then hours, then IQ, and etc. Okay, is everybody following? Okay, I say that, okay, for all these columns in basically this list, do this, print column. So this is the name of the column. So if I only print column, so if I just get rid of this one, so what do I get? So this is, I see wage, hours, so one by one, right? My iterator is wage, so print wage. Then the iterator is hours, then IQ, then education, and etc. Now I'm gonna say do some specific thing to that. I'm gonna say, okay, print column and so now I'm going to use df column. Basically, remember, column in the first iteration is going to replace by wage, second, hours, third, IQ. Out of that, I want to look at the unique numbers, unique elements in that column. So for that, we're going to use the n-unique from NumPy package. So the function is n-unique, right? So let me give you an example. If I want to see how many unique, for example, it's black, and then I do n-unique. Or sometimes this tab doesn't work, but anyway, so in unique, oops, we have black. Yeah. Oh, because I have an extra U here. Okay. And unique, so that. Yep. Let me see. It should auto-complete it for me. Unique. All right. So you see, if I only look at black, so it says that in your data set, there are 2 unique values for black variable, right? I'm doing, so I could have typed this line 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times, or put it in a for loop, right? So I prefer to put it in a for loop, right? So I'm going to go ahead. Actually, I'm going to keep all these things and push it to the repository. You may find it helpful. Now, if I do it this way, it's going to go over that for loop and tell me what are the unique numbers of variable elements in each variable. So weight 449 unique observations. So it definitely should be numeric. It's not categorical variable, right? And then the rest of it, hours 37, IQ 80, education 10. I'm a little suspicious about education, so I can dig further into that. Experience 22, tenure 23, age 11. So again, maybe the data set is very restricted. Go from 30 years to 50 years, and then we have only 11 different years, right? Married, black, 2, 2. So definitely I have to think of these 2 as categorical variables, right? And then modern education, father education, 18, 19, that's totally fine. We can also see tabularize, we can also tabularize the variables, it's not see. We can tabularize the variables of interest using value counts, right? So I can count the values of each of the columns. Remember, I want to see how, I know I have 2 types of 1 and 0 for black. So 1 black, 0 non-black. I want to see how many of the variables in the, how many of the observation in the data is black, how many is non-black, how many is married, how many is non-married. For fun, I added the education as well here because I was suspicious why I have only 10 level of unique education levels. So let's see, what do we get? The same story. I'm going to say that for columns in this list, black, married, education, let's go ahead and print out the value counts. Value counts is a function that it's going to give you the breakdown of the values in your variable, right? So for example, variable black, there are 120 black in the data set, 815 non-black. Does everyone see that? Okay. So this is important because you want to see if you have a balanced data. If black was my, so if it is in an explanatory variable, it's not that important, not that of a big deal. But if your target variable, imagine you're doing classification models, at the end of the day, you want to say pass, fail, right? You have thousands of observations, 995 of them are pass, and only 5 of them is fail. You cannot train a good model out of that. It's very unbalanced. Does that make sense? So that's why we have to, for categorical variables, we can look at the value counts and keep in mind that, remember, if I do machine learning, maybe the accuracy is going to be ridiculously low or high. That's the reason, because the data is very unbalanced. So that's what we get out of the EDA, the goal of EDA. Okay, so here, this is fine. Again, it's in the right-hand side variable. I'm not that concerned. And married, 100 versus 835, also fine. And again, for fun, we did education because I was curious why we only have 10 unique level of education. It seems that we have 9 years of education, 10, 17, 11, 15. Yeah, maybe this is high school, this is college, this is a 2-year college, 2-year dropout college, things like that, right? But it makes sense, so I'm not worried. I know that education should be numerical, right? I just left it as an example. If you want to see what's inside of each of these classes, each of these variables, you can do value count. All right. Is there any questions so far? How do you feel about the speed? You good? All right. So apparently, black and married should be categorical variables. So, and the rest of them should be numeric. So let's change them to categorical variables. This is a very good this is a common practice. I want you to, if you want to memorize anything, memorize the methods, the steps. Do not memorize the functions themselves, right? So for example, you have to do this first, and then after that, and etc., right? So it's a good idea to put your categorical, the one that you want to make them categorical variables, just give them, put them in an object, call it categoricals. Just remember that the name of the categorical variables is listed here. And then the one that you want to make them numerics, just call them numerics. If your data frame has a time series, you can say timestamp and then put a list. This one doesn't have a timestamp, right? So now I have categoricals versus numerics, right? So I know that if I look at the categoricals, what is inside categoricals? It's going to be those black and married. What is inside numerics? It's going to be this, right? Here I have a question for you. Can you think of an easier way to do this? So guys, look at that. I manually typed in wage, hours, IQ, education, experience, tenure, and etc., right? But can you think of an easier way to do that? What's the application? The application is, let me tell you the application and then come to you. What if you have 200 variables and you want to drop only 2 of them? So do you need to type in 198 of the names? There's a good chance that there's a typo and things like that. So that's the motivation. And now see how we can do it otherwise. So Ryan, what do you think?
Well, I was thinking of a different thing where you use the split function so that you don't have to type all those quotations. But
yeah, split is going to save you the quotation parts,
yeah.
but still you have to type in a lot.
Yeah.
But it's a good start, right?
Yeah.
Right? So again, there are some things that I may do in the class. It's just for more efficient way of coding, but it's nothing necessary, right? Just keep in mind that, maybe when you're doing, of course, the better coder you become, the more time you can save. But let's practice one of them. So how can I do that? I'm going to say df drop. I will drop. Remember, out of all of the columns that I have, I want to drop black and married, right? Because because I want to keep the rest of them numeric, right? So this is a trick that I really like to do. And when it comes to splitting the data in train set and test set, I'll do it in our machine learning notebooks as well. So if I do something like this, I have to pass the axis, right? So because back to the question that we had on this slide. So axis 0 here means that, again, do not memorize anything. But I know that I'm in Pandas, so 0 is rows, 1 is column. Just to scroll down, it says that 0 is index is rows, and 1 is column. So we are dropping something from the column, right? So axis, I set it equal to 1. And then I'm not going to put in place is equal to true. If I put in place is equal to true, it's going to drop black and married from the data frame and then update the data frame without black and married. I don't want to do that to my data set. Does everyone follow? So I want to temporarily drop black and married from this data set, right? Now that I have dropped it, I can look at the columns. You see, I was able to pick the rest of them, right? And then because it says an index, I just want to come up, make it as a list. Because remember, guys, these are lists, right? And I have bracket, these are lists. So I can say something like this. Give me the list of these things. Oops, I don't know what I did, df. You see, so I don't need to type them in. Does that make sense? Again, there are tricks here and there. So I'll just leave it like this. You can practice it. There are tricks here and there that it's good for you to learn those ones. So these are very common ones, okay? And I will emphasize them when I'm coding in the class. If something by experience has happened to me again and again and again, I just let you know that this is important. You'll see it again. So that was one trick. And guys, remember now, so the cool thing is that if I look at the column names again, black and married are back, right? You see, black and married are back because I didn't say in place is equal to true, because if I say in place is equal to true, it's going to be very bad. I'm not going to do that because if you do that, it's going to completely drop black and married from the data frame. I don't want to do that. Does that make sense? Okay, so let's go ahead and remove the in place is equal to true. And yep. So now, I'm going to go over 2 for loops to change to what's the goal? We want to change the categorical variables. We want to change black and married to categoricals and keep everything else as numerics. So let's see how we can do that. Now I'm going to construct 2 for loops. So the first for loop is going to take every single column which must be categorical and then change their type, right? So I say that just pick these 2 columns. The categoricals are black and married, guys. Remember black and married. And for those, df call is equal to df call as type category. So what are we doing? I'm changing the type of, let's say this is black. df black is equal to df black as type category. I'm changing the type of whatever it is to category. Is everybody following? Okay. So if I run this line, and now if I look at the info of the data set again, look at that. These two variables changed. They used to be integer 64, and now they are category. Are we good? I'll run this for loop again for numerics. So I said, okay, change all the columns in the numeric. What is numeric? Everything else we just created here. And now here, I say, okay, take each of those columns, and I'm going to use a function from Pandas. It's called toNumerics without s. So I say pd.toNumeric, and then you have to pass the column that you want to change. And there is this trick here, which is errors equal to course. So if I do that, it's going to go ahead. I want you to pay attention to these ones, right? It's going to go ahead and make them all numerics. So in this data set, they happen to be numeric already. In the data set that you're working for your homework, some of them are objects. So for example, they used to be object, object, object. If I change this to numerics, and then it's going to change them to numbers, okay? Now, just read through this line. Alternatively, I could have used the df.asType, exactly the same thing as we did with category, right? And then use integer 64 or float. Why did we prefer pd.toNumeric? This is a question for you, okay? I just leave it as an exercise, and if you found the answer, just send me an email or the TAs. So and this is, guys, this is going to be, I'm going to ask a bunch of questions in the class, and I don't give you the answer, just leave it as an exercise. The goal is to teach you how to Google. So literally Google something like this. Why is it better to do pd.toNumeric versus asType integer 64? And just go over Stack Overflow and see what you get, okay? And hint, it's because of this course. Again, you Google it and then see what's going on. But in a nutshell, the errors equal to course is very useful, because if there is any NA, if there is any missing value, so for example, there's a space in the data set, right? So instead of putting 10, the data set doesn't have 10, has a space. It's going to replace those things with NA for you. So that's very helpful. But again, I want you to just go over Stack Overflow and see if you can find some answers. Now, my data set, at least in terms of type of the variables, is ready, right? So the type of variables is exactly what I want. I can look at the describe again, and look at that. I have two categorical variables. Do you realize that when I do the describe, I'm looking at the summary statistic, there is no sign of married and black? Because by default, this describe is going to give you back the summary statistic for numerical variables only. If you want to see everything, you have to say describe include is equal to all. If you do include all, now you can see black and married too. And then you will see some more statistics, for example, number of uniques, top, frequency, and etc. We know that 2 unique values for married and 2 unique values for black. Are we good? All right. What do you learn by comparing the mean and median for wage? So here's a question. This is more type of an econometric question for you guys. If you compare this number and median, so 959, let's say 1,000, 957 versus 905. So what do you realize? Mean is greater than median. So what's the implication from your statistics, econometrics?
Right tail?
Yeah, it's going to be right skewed, right? So the wage is going to right skewed. If it was econometrics course, I was concerned. I would have so let's look at the second question. Which of the all else assumption is violated if it is right tail? And if wage is your target variable? Your errors are not going to be normally distributed anymore, right? We are going to have heteroscedasticity. So I have heteroscedasticity. I prefer to use log wage instead of wage. But this is not econometrics. This is machine learning. Maybe at this stage, I don't care. Does that make sense? I know that if I do it, it's going to do a better job to the model, but let's leave it like that. Okay, so this is the answers to these 2 questions. Now, the next step is to handle the missing values. So I'm going to use isNull function, and well, actually, let me do it step by step. So, well, let's make a new cell. If I do df.isNull, basically it's a bunch of true false, right? True, false, true, false, true, false. We know that this is not useful. When it's false, it means that there is an information here. So married, it's not null. There is an information. So I don't see any. So yeah, there are a bunch of truths here. So these are missing variables, right? So, but this is not informative, right? Specifically when the data has millions of records. So I do sum. If I do sum, it's going to count them for me. So there is no missing values here, but for modern education, there's missing values, right? And maybe this is not informative either. So I'm going to say divided by the length of the data frame. If I divide it by the length of the data frame, it's going to, well, len. It's going to give me the proportion, right? So it seems that in this data set, 8.3% of the data is missing for modern education, 20% is missing for further education. Okay. Well, this is not good at all. So let's visualize it. There are some visualization functions that we can use as well. So let's plot the NAs. I'm going to use a heat map from Seaborn. So if I do SNS heat map, again, what do you want to plot? I want to plot the NAs. And there are tons of things that you can do with these heat maps. And I'm not going to spend some time going over the details, guys. Remember, as I said, if there are 100 units in Python, I know only one. That's not the goal. Okay. The goal is to, I'm emphasizing, learn the theory of machine learning. The rest is just tools. So you can copy and paste. So for example, when I was putting together this notebook, how did I do that? I Googled it and I just found this one more satisfying. I paste it here, literally paste it here. Okay, so this is what you could do. So this shows you the missing values. So look at that. There are lots of yellow ones here. So it's already assigned to me that further education is missing a lot. So I already know that it's 20%. So I have to do something about it, right? Because the number of NAs in the further education, modern education is 5% and 20%. Well, further education is 10, 20, modern education was 8 something. We should not keep them in the regression model, or at least we could do an imputation. So for example, we can go ahead and replace all the missing values for the modern education with their median or their mean, right? So here in this example, I'm going to go ahead, and this is just for learning purposes. I'm going to go ahead and drop the further education completely because I don't want to lose 20% of the data. Does that make sense? I'm going to go ahead and drop further education completely. So on the positive side, the data is not going to suffer from losing 20% of the data. On the negative side, I'm missing an important variable. Okay, but there's a trade-off. You have to figure it out, right? So again, for practices purposes, I'm going to go ahead and drop the further education and impute the modern education with median. So let's do that for practice. So I'm going to drop further education and look at that. In place is equal to true. Why do we need to in place is equal to true? Because we want to replace the original data frame with the new one. In the new one, further education is completely dropped, right? Now, if I look at the columns, you cannot find further education here. So because we put this in place is equal to true. Okay, now let's impute the modern education by the median. Why median? If I go back to this, one of the summary statistics, look at the education, modern education. What is the mean? 10.6. What is the median? 12. So what's left skewed or right skewed? Mean is less than median. It's left skewed, right? And because it is left skewed, I know that average is not a good statistics for the center of the data. So I'm going to use median. So these are just some small little things that you will learn them by practice and experience, right? Okay. Guys, I cannot emphasize it more. Do not lose perspective. Okay, so I'm going to go ahead and say that take this column, modern education, fill NA. This is a function, fill NA. What do you want to fill it with? I'm going to fill it with the median of that column. X is equal to 0, in place is equal to true. And then now if I look at the, well, I can look at the info. So I know that the modern education, it's filled. There's no any other missing variable, right? So now the data got rid of, well, this should not be, yeah. It's filled. The NA of the modern education is filled with, well, if I run this line again, you're not going to, let me actually copy it because I don't want to change the. You see that the data is going to be clean. So this data is clean. Now it's ready for us to move on. Now we can do a bunch of visualizations very fast. So for example, one of the variables that I always want you to look at the distribution is your target variable. So here, the target variable is wage. At the end of the day, we want to predict what is the wage based on some explanatory variables, education, age, and etc. Right? Is everybody following? So do the distribution always for your target variable because it's very informative. So let's do that. We are gonna use this plot from SNS. So what do you want to plot? DF wage, beans, and yeah, guys, you see, if I say beans is equal to 30, and look at that, rog is somewhere here. If I write rog, I don't need to keep, I can easily change the ordering, right? So I can say rog comes first, and then beans. It doesn't do anything as long as I keep the labels, right? What is rog, by the way? Rog is going to, we have a rog plot, if you haven't heard the term rog plot. So rog plot is simply, well, let me actually show you without rog, and then the picture is better than an explanation. See, this is a distribution of the data. Now, if I go ahead and change rog is equal to true, look at these little things that's going to be added at the bottom. These are literally the number of observations, right? So I can see the majority of the data is concentrated maybe here. It's right-tailed because there are a bunch of outliers to the right tail. And this is wage, not surprising. We have some billionaires in the right tail, and then they're going to push the median up. That's why, the mean up. That's why the average is not a good representation of the. So for example, if someone tells you that, okay, US household average income is 65,000 per household. This is very good, Lars. Be careful, this is biased. You have to look at the median income, not the average. All right, so challenge. I'm not going to give you the answer of the challenge now, but before the next class, I'll publish the answer of the challenge, okay? So I want you to practice it. Can you plot the distribution plot for basically the histogram for wage, but I want you to plot it for black versus non-black on the same graph. So this is your first challenge. The second challenge, when you do that, you'll see that the size is ridiculously small. Can you change the size of the plot? So this is your first. And I want you to replicate this. And whenever you want to practice it at home, do not type anything here and then run this cell. Because if you do that, it's going to clear this one for you, right? Make a new cell above it and then try to play around with it, right? If you accidentally delete this one, just pull request from the repository again, and then. Does these things make sense? Okay, good. Guys at home, do you have any questions? You're good? All right. So try to replicate this one. Now, then, for example, I can, again, this is for machine learning, most probably we don't need that, but if you wanted to do some log transformation, for the sake of completeness, I just put it here. So for example, how can I change wage to log wage, right? What's the motivation? We know that if you do log transformation, it's going to make the distribution more normal, right? And so for that reason, we do log wage. So if I do log wage, so we can use a log function from NumPy package. So that's why we do np log, and then just replace. We'll make a new variable, call it L wage, log wage, and then add it to the data. Okay. All right. The next one is Corollogram, or here we're going to call it heat map in Python. Corollogram basically shows you the correlation between variables. In many applications, it is useful to know what's the relationship between variables. So what variables are, at the end of the day, are going to become more significant, right? But remember, this is machine learning. If you have hundreds of variables, do not plot the Corollogram. It doesn't make any sense. Are you following? Okay, because there are 100 variables, you don't want to. And at the end of the day, we're going to use dimensionality reduction methods, maybe only work with 10 of them instead of 150 of them, right? But it is what it is for the wage. And how can we read these numbers? So for example, it says that your wage is negatively correlated with hours, which is surprising. Well, not surprising because it goes upper in the corporate ladder, and then maybe more higher degree you have, not necessarily work, but the number is very, very small. It's positively correlated with IQ, not surprising, education positive, experience barely positive, tenure positive, age positive, moderate education. And there's a huge literature out there, by the way. You can relate the parents' education with your future wage, and it's positive and significant. Okay, then we're going to look at the pair plot, and because to save some memory from the computer, I'm not going to plot the pair plot for all the variables. I'm going to plot it for wage, education, and experience, and age, right? Again, use it as a template for EDA. And so this is my pair plot, and pair plot takes a little time. So don't do it to a data set with hundreds of variables, right? Your computer is going to crash. And if that happened, come here, go to kernel, and then well, because here is not busy, so you'll see an option, restart kernel, things like that, okay? So this is a pair plot, And so what's the advantage of looking at the per plot for the sake of machine learning? So you can at least look at the distribution of your wage, and if there is any obvious relationship between variables. So for example, wage and this one, it's positively correlated, right? And then maybe with this one is negatively correlated. And again, EDA, the whole point of EDA is to tell a story before working with the model, right? I leave this one as an exercise. I want you to plot the same EDA. So this is the same EDA, but we're gonna plot it for merit, different merit versus single, right? So merit is 1, single is 0. So by looking at this per plot, what do you get? So for example, it seems that the merit people on average are getting higher income. Also, there's no difference in education. And I can see when it comes to experience, merit people, it's more toward to the right, you're more experienced. And this is not surprising, right? But because there's a good chance that merit people are older, so that's why their experience is higher too, okay? Again, you have to try to connect the dots in your head when you're in the EDA part, and then jump into the model. Age, so not surprisingly, the merit, and this is really interesting. Look at that. The distribution for merit is 2-hump shape. Are you surprised? So what does it tell? It says that the majority is around 30, they're married, and then maybe they get divorced. Or maybe if you don't get married up until 30, you're not gonna get married, maybe. And then afterward, there's another hump. So this is really interesting observation, right? I had no idea. But again, you look at the data and try to, as you're doing the EDA, try to come up with the stories before modeling. Okay, now we're almost done. And the other thing that I want to teach you, which is not available in the Python crash course, is using group by. Group by is a very powerful function from Pandas. And so we apply it to data frames. Let's see what is the goal here. Imagine we want to summarize the data based on different categorical variables. And we're going to do that by group by function, right? And guys, when you hear me using functions versus methods interchangeably, these are two, you can use them interchangeably. Methods are usually applied to an object. So you do, for example, I do data frame dot method, but function, I write function open close parenthesis something, right? But they do the same, they do exactly the same thing. For example, they're gonna take an input, do something to that, give you an output, right? So if you hear me saying methods or functions, they're the same. Technically not, but practically you can think of them as the same thing. And I just told you the difference. Okay, so let's see what we want to do. Imagine I want to summarize the average wage, education, and age for 2 different classes, married and non-married. Does that make sense? This is a very good observation, right? So maybe something useful. Let's see how do we do that. So actually, I'm going to say, okay, let's look at the data that you want to work with. I want to get the summary statistics for wage, education, age, and then the categorical variables are black and married. So I have to keep them in the model. I'm going to say, okay, group by. And if you look at the features of group by, so we see one of the important one is by. So what do you want to group them by? So I want to group them by, let's say I want to group them by merit. Okay. If I only have one variable, I don't need to put a bracket, or this is bracket, yeah, bracket. So if I do like here, it doesn't hurt, but as long as I have only one variable, right? So if I do something like this and I run it, you see the output is, it doesn't tell you anything, but behind the scene, it's looking at the data set and group all the variables by different categorical variable that you're passing, right? So here by merit. Then you want to say, what do you want to do with that? I say, I want to take the average. You can look at the standard deviation. Does that make sense? You can call these different functions. So I want to look at the average. Now look at that. So here's the difference. So basically, I can drop one of them. And by the way, if I go ahead and escape on a cell and do double D, it's going to drop the cell, right? So the cell. And if you did it and you wanted to undo it, it's not Control Z, it's just a Z. If I do Z, it's going to undo. You have to make sure that you're in escape mode, not edit mode. Okay. All right. So I group by, I look at the average. So I give you an exercise. Can you do group by multiple columns? I want you to Google this and then come back here and we'll Will I give you the answer? No, I didn't. Come back here and try to play around with it, right? And this is not that difficult. If I, well, actually, let's do it together because this is easy. If I simply go ahead and do black here, it's going to do the job for me, right? This is very useful, right? Because it says that, okay, married, within the people who are married, what is the average of black? What is the average for non-black, right? For married people, what's the average for black, non-black, etc. So these are really, really interesting. So again, if it was econometrics, I would go even further and start interpreting these things, right? So it seems that on average, regardless of marital status, on average, black people are getting less, right? 12.77, 12.38 versus 13.5 and 14.07. So this is education, sorry. If you look at the wage, it's going to not surprisingly different. It's going to be less. All right, so that was the group by. So I'm going to go ahead and drop this and leave it as an exercise. So you do it. Okay, now the power of group by is not only looking at the summarized table or tabularized. The power of it is when it comes to visualization, right? So let's try to visualize this thing. So I'm gonna do exactly the same thing, right? I'm gonna say, okay, group by them by merit. You want to compare the averages. Let me see if it is STD. I don't remember. I don't remember if it was STD. Let's see if this. Yeah, STD works. Okay, so this is a standard deviation, right? So it can pass any function that you. If you don't know the name of the function, just Google it. What are the methods in NumPy? Arithmetic methods in NumPy. So one of them is mean, one of them is STD, things like that, right? Okay, I'm doing exactly the same thing, and however, I want to make a new data set. I want you to stare at this data set. I have wage, education, age, and these are the married. Married is 0, 1. I want to make this married to become a column itself. Why? Because if I have a column, then I can plot it. I can say, okay, take that column as X variable and then another column as Y variable. Now let's look at the plot. How do we do that? If you remember that from time series notebook, we have to reset the index. If I reset the index and look at the data set again, now it's going to do what I exactly wanted. I wanted to make this married a new column. And because it used to be the index, you see? Now it's not index anymore, it's a column itself. And now index is 0, 1. So I can go ahead and give it a new name to the index. You can call it 1, 2, whatever. Is everybody following? All right. Now, this is a data set that I'm interested in. So I'm going to give it a name. I just save it as df group married. You can call it anything. Now, I want to do some interesting plots, right? So for example, I want to do a bar plot and look at the averages, right? It's basically going to compare the averages, average wage, right? So I say do the SNS bar plot. The Y variable is wage. So I'm going to look at the wage in the vertical axis, and horizontal axis is married. What is the data set? Data set is the one that I just created, this one. This is my data set, right? Look at the output. Again, I leave you with a challenge. Replicate the following chart. It's not only wage, it's not only marital status, 0, 1, it's also black and maybe white, non-black. So this is an exercise for you. Try to go, again, take these exercises very seriously, guys, right? And try playing around with it, Google it, Stack Overflow, and you should be able to find it relatively easy. The difficult, so this is very easy if you Google it. The difficult challenge was this one. This one, this is difficult. So if you can figure this out, that would be awesome. All right, and then finally, you're done in terms of the EDA part. However, if you, down the road for the course, we're gonna make some variables, we're gonna transfer them to dummy variables. So here's just for your reference, how you can make dummy variables in Python. And again, you're done with the EDA. So for your homework, you will be done around here. And then, of course, you have to put some more narration to the homework, right? So this is the observation, this is what we think, and etc. Okay. And making dummy variables. If you want to make dummy variables, we do something like this. I make a new data frame called a df dummy, and this function is from Pandas, gets dummies. And as you can guess, it's going to take your data frame and make dummy variables. When I say drop first is equal to true, it's going to drop the first class of your category type of your dummy variable. Econometric word. Do you remember if I have a categorical variable with 10 classes, How many dummy variables should I use? 9, right? Because if I use 10, it's dummy variable trap. The OLS is going to complain. It's perfect linearity, right? But this is machine learning. We can get around that. But however, there are some cases down the road in our lecture videos that we need to make variables dummy variable. So if I go ahead and do that, look at the head of the new data set, which we call it DF dummies. Look at that. Married 1 is 1, black 1 is 0, and etc. Here, because we only had 2 classes in each of them, married and black, it really didn't make any sense to make them dummy. But I have 3 classes, 4 classes, and etc. The dummy variables make more sense. All right. And do we need to use drop first is equal to true? Does this matter for machine learning? So the answer for machine learning, not necessarily. In some models, yes, some models, no. But in econometrics, we have to because it's dummy variable trap. Okay. I tend to put more links than only one for the following lecture. So make sure that these are the follow-ups of the class. Make sure to go over those links as well. And in the last couple of minutes, so I give 1 minute to you and 1 minute to me. So is there any questions left, guys, from home? All right. So your homework is going to be an EDA of a very, very nasty data set, which is New York City property sale. The data set is available on Kaggle competition. The data set is absolutely ugly. And the reason I want you to work with that is if you handle that data set, you're going to be in good shape for the rest of the data sets, right? However, I know it's very difficult and the homework is due on Monday. So I give you the answer key as well. So what's the point of doing that? So bear with me. So if you just type in New York City property sale, and then my name maybe, well, PJ, well, I'll give you the link to in the homework, which I'm gonna publish tonight, hopefully. PJ Algo trainer. And then if you do Kaggle, yeah, Kaggle competition, it will take you to the Kaggle competition link. Again, don't worry about the link. You don't need to Google it. You will find it. So this is a data set that I want you to work with. And I'll give you an introduction to Kaggle in the homework as well. What is Kaggle? We're going to work with some data sets. And this is something that you can put in on your resume. It's going to shine. And that's the purpose. And then the point of Kaggle is that if you go to notebooks, you can see what other people has done to this data set. You can learn a ton from watching other people's coding. For example, for this exercise, if you do EDA, and my contribution to Kaggle is only this one because I use it in my classroom, okay? But I encourage you to just go ahead and make an account and then make some contribution to Kaggle, right? Because maybe, who knows, after a while you get, your score is getting higher and higher. So somebody upvoted me 1%. Probably my student. Okay. So if you click on this one, this is the answer key to your homework too. So I'm giving you the answer key. So what's the difficult part? The difficult part is that I want you to go ahead and read every single line of this EDA. Try to understand it. Okay. So, and as you can see, and I did some explanation as well. So we look at the data set and we do it exactly the same as we did in the class. Starting what type of the variables should be, categoricals, and etc. And then again, this is a very ugly data set. There are a bunch of NAs, it's nasty, and we have, you see the answer key, this is the answer key. Just go over the codes one by one and try to follow with the code and try to have fun with that. You do have the answer key. This doesn't mean that you can postpone it to Sunday night. It's a long one, right? And you work as a group and just try to have fun with it. So this is your homework for, and I'm going to publish this homework tonight. All right. So just bear with me 1 more minute. Guys, do not lose perspective. Don't feel overwhelmed with the Python part. Okay, this is completely normal. It happens naturally when we practice more. What I want you to take away from this course is learn the theory of machine learning. For example, next week is going to be super important. Make sure that, and it's going to be completely theory because I'm going to go, before starting the models, I'm going to go over the basic concepts in machine learning, like cross-validation, bias variance trade-off, regularization, and things like that, right? So make sure that you attend the next week and you take notes and you watch the videos before coming to the class, the YouTube videos I'm going to post, take the quizzes. And that aspect of the course is a lot more important to me as your professor than the Python part, right? Python, you can always Google. But those things, there are many people that claim that they know how machine learning works, but they have no idea because they only apply it. I want you to go beyond application alone. I want you to understand what's the difference between machine learning and economics and what you're doing. Okay, so that's what is more important to me. Okay, so I'll leave you with that. Have a productive weekend, and that's it.
Thanks, John.
Okay, so because I'm recording it, I'm going to show it to you. So guys, for example, we made a bunch of changes here, right? Now I'm going to go ahead and push these changes. I call it updates to my repository. If you go ahead and pull request again, you will see the most updated version. So you'll see this one. So it's already up there. All right. Pause. Stop here.